Hello everyone. Today's lecture 3 on statistics. I am Shubham Keshri. So let's start. So in the previous lectures, we have covered how we captured the deviations. We have also seen range, mean deviation, and mean deviation of ungrouped data, mean deviation of group data, mean deviation of discrete frequency distribution, and mean deviation of continuous frequency distribution. Today we will see what variance is and also standard deviation and how they are interconnected, standard deviation and variance. We'll see how we calculate these uh, variance and standard deviation for ungrouped data and for group data. So first let us understand why we are going for variance. So mean deviation we have calculated about the mean or median and it required absolute values of deviation. Therefore, we needed to calculate deviations from the central value and then find their average. So if this absolute values of deviations were not taken, we have seen in earlier lectures that if it was not taken, then the positive and the negative deviation will cancel out each other. And for this reason only, to surpass this problem, we had taken absolute deviation. But taking absolute values of data creates some problem. If you are aware that taking differential of absolute values is difficult. And there are more issues on taking the absolute value of a number. Therefore, instead of taking absolute deviations, we can take the square of deviations to overcome the difficulty of sign. So this squaring of deviation has two benefits. What is the first benefit? Squaring of deviations make them non-negative. So either it can be a positive deviation or it can be negative deviation. Squaring those numbers, either positive or negative, makes them all non-negative. Therefore, it avoids cancellation of positive and negative deviations. So we have overcome the difficulty of cancelling out the positive and negative deviations when we are taking the sum. Therefore, this is appropriate. This squaring of deviations has one more advantage. What is the next advantage? Squaring of deviations between the data point and the mean. What it does, the larger differences are given more weightage. So you can see this with an example. So suppose the mean is 5 and we have a data at 3 and a data at suppose 1. So this deviation is -2 and this deviation is -5. So when we take the square of these deviations, -2 square is 4 and -5 square is 25. So you see the deviation which is less away from the mean has less squared value as compared to the deviation which is farther away from the mean, which is larger squared value. So what it does, it recognizes that points farther away from the mean may be more significant. So points that are farther away from the mean has more squared value. Therefore, the deviation is captured in a more elaborative way. So point nearer to the mean has less squared deviations than the points farther away from the mean. So when we calculate this squared deviations, more value may correspond to more deviation of the points from the mean. So if x bar is the mean. Okay. So we have captured two important factors. First, we are sorry, not here. First and second. So first, we are getting non-negative values because we are squaring the deviations. So both positive and negative values are getting squared up. And also this, we are capturing that point farther away from the mean are becoming more significant now. Okay. So now we'll go on to what is variance and what is standard deviation. So variance is a measure of spread of the data. So earlier when we were calculating mean deviation, we were saying that summation of xi minus x bar modulus by number of data, if this is for ungrouped data. Now we are saying that this deviation, we will square it up. And therefore this value after squaring it up is called variance. So variance of a data is summation of xi minus x bar this is x bar whole squared by n. So this is what variance mean. It is saying it is the mean of the square of deviations from the mean. So what does this sentence say? We are calculating the mean of the square deviations. So summing up all the values by dividing by the number of data points is actually taking the mean of the square deviation. So suppose we have deviations as 3, 7, 5, 4, 3, 2. These are deviations from one mean. Okay. So we are squaring these deviations and we are summing those deviations up, and then we are dividing by the number of deviations. So 1, 2, 3, 4, 5, 6. So we have 6 data points. We had 6 xi's. So this we had 6 data points. I is equals to from 1, 2, 3, 4, 5, and 6. So we had 6 data points, and we had calculated the mean of those data points, and the deviations of each of these values were this. So what we were doing, we were calculating the mean of these deviations, square deviations. So this is what variance is. Okay, it is the mean of the square of the deviations from the mean. Variance is calculated both for group data and ungrouped data. We will see examples of both, how we calculate mean for group data and ungrouped data. The formula for variance of ungrouped data is calculated as sum of the square deviations of the mean by total number of deviations. So you need not remember variance like this. You should always remember it is mean of what? Mean of squares of deviation from the mean. Okay. So first we are calculating the deviation from the mean. We are squaring it up and then taking its mean. Okay. Got it? It is here also. So first we are taking the deviations from the mean, squaring it up, and then taking the mean of those deviations, right? So this is variance. So if we have variance, why is the need for standard deviation? So what is the need of standard deviations? We have a quantity which is known as variance. So what is the issue we have with variance such that we need one more measure which is known as standard deviation? So let us see that in the next slide. Here it says that variance involves square of the sum of the squares of the deviations from the mean. Okay. Variance involves sum of the square of deviations from the mean. So we are squaring these deviations. Okay. Now the unit of observation and the mean differ from variance. So when we have, suppose, some data points like 6 centimeter, 7 centimeter, 9 centimeter, 10 centimeter, and so on. Now when we are calculating the square of the deviations from the mean, we are getting these units as centimeter square. Okay, right? So this unit and this unit are different. So one is in centimeter and one is in centimeter square. Similarly, if we have other units apart from centimeter, so those units will also be squared. This is the issue with variance. So to overcome this issue, standard deviation is taken. And what is standard deviation? Standard deviation is just the square root of variance. So variance was, and remember, we write variance as sigma square. Why? Because we write standard deviation as sigma, and standard deviation is root over of variance. So variance will be sigma square. Therefore, we are writing variance as sigma square. So the formula for variance was, or not just the formula, what was variance? Variance was the mean of the mean of the square of the deviations, right? So this was the formula for deviation, sorry, variance. So what will be the formula for standard deviation? Just the root of this, square root of this. So root under of summation xi minus x bar whole square by n. Okay. So standard deviation is an appropriate measure of dispersion about the mean. Why? Because the unit of standard deviation is same as the data points. Now, as we had these units as centimeter square, we will take the root of these values. Then we will get the unit as centimeter. So this unit and this unit is same. Therefore, standard deviation is an appropriate measure of dispersion from the mean. Okay. So you got the point, what is variance and what is standard deviation. Now, keep one thing in mind. These formulas which we have written here are for ungrouped data. Okay. Why is it so? Because we're not telling that this xi's have some frequency. We are saying that we have some data points and those are xi's. Okay. We'll see one example and it will be more clear. So we have an example here, variance and standard deviation of ungrouped data. And again, we will do this using a table. Always remember, in this chapter, using a table is very makes the job of calculation of deviation, any type of deviation, mean deviation or standard deviation, easy. So always use a table. Okay. So since we have ungrouped data, we have these data points and it doesn't have any frequency because these are not grouped data. We have done an experiment and we have observed this data. So 2, 4, 6, 7, 8, and so on. These data are observed and it can be repeated because these are ungrouped data. So we could have also had a 2 here, but it is 4. Okay. So these are ungrouped data. So how we calculate? So what we'll do, we'll take the mean of this data. Why do we require the mean of this data? Because we have to calculate the deviation from the mean of each data. So suppose this is the number line and this is the mean of the data and these are xi's. Suppose this is x1, x2, x3, x4, x5 and so on. These are x5. So we need these deviations, the difference between the data and the mean of the data. So we have calculated the sum of this data, which is coming out to be 96. And we have 10 data points here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we'll divide this by 10 to get the means. This is 1 by 10 and we get 9.6 as the mean of the data. So this we know. This data point we know. It is 9.6. Now for calculating the deviations, we'll do each data point minus the mean. So 2 minus 9.6 is minus 7.6. Similarly, 4 minus 9.6 is 5 minus 5.6. 6 minus 9.6 is minus 3.6 and so on. We calculate these data points. You see, this deviations decreases and then increases, right? You can also see it here. When this data points approaches the mean, it decreases and again it increases. Why is it so? Because we have arranged this in ascending order. It might not be true always if the data is not arranged. If the data has been arranged in the, I'm saying that these deviations are just increasing downwards, right? Increasing downwards. This is because we have arranged the data point in ascending order. It is not decreasing and increasing. It is just increasing and increasing because we have not taken the absolute value. This is just the deviations. So if this data was arranged in descending order, we would have seen decrease in deviations from above to below. Okay, so there is no such trend because these points could have been arranged in any order. So this trend is not there. Now what we'll do, we'll take the square of these deviations. So each deviations are squared. 7.9 squared is 57.76, 5.6 squared is 31.36 and so on. So what is variance? Variance is mean of this value. So for mean, we have to calculate the sum. So sum of these values is 26.6, 266.4 and the mean of these values are 26.64. So sigma squared, which is equals to 1 by n summation of xi minus x bar whole squared has come out to be 26.64. Now, this 26.64 is the variance. It is not the standard deviation. So to calculate the standard deviation, we have to take the square root of the above value. So we have taken sigma is equals to root under of 26.64, which comes out to be 5.16. Okay. So you see, they are saying that the standard deviation of this data is 5.16. Okay. So this is how you calculate the variance and standard deviation of ungrouped data. This was one example. Next, we'll see how to calculate variance and standard deviation for group data. So group data could be of two types, as we have seen earlier when we were doing mean deviation. It can be discrete frequency distribution or continuous frequency distribution. Okay. So first we'll see how to calculate variance and standard deviation for discrete frequency distribution. So in discrete frequency distribution, xi will be there and we will have fi. So for each xi, suppose xi is 2, for each xi there will be a frequency. It is saying that 2 has been occurred so many times. Suppose the frequency of 2 was 7. So it says that the value 2 was observed 7 times. So how we will calculate the variance and standard deviation? We will calculate the variance and standard deviation using this formula. Sigma squared is equals to 1 by n summation of fi xi minus x bar whole square. So this sum is over I, where n is what? N is summation of I fi, summation over I fi. So you see this is very similar to the mean deviation. When we were calculating mean deviation, MD, the formula was over x bar, the formula was summation of over I fi modulus of xi x bar by summation of fi. So you see it is very similar. This formula and this formula is very similar, right? And standard deviation is just the square root of this value. So we will just put a square root over the variance. Now we'll see one example. So this is an example of discrete frequency distribution. So we will be given this value. So this value will be known in the question. Will be given xi values and the fi values. So what does it say? It says 2 has been observed 3 times, 4 has been observed 5 times, 6 has been observed 4 times, 7 has been observed 6 times. So this is the frequency and this is the data point itself. Okay. So what will we do? So as the table is very similar to the mean deviation. So first we'll calculate fi times xi. So we'll multiply 2 times 3 is 6, 4 times 5 is 24, 6 times 4 is 24 and so on. Right? So we will calculate this fi xi. Now to calculate n, we know that n is equals to summation of fi. Right? So we'll sum these fi's. We got 40 observations. And we will also sum fi xi. Why do we need the sum of fi xi? To calculate the mean. So xi is equals to summation of fi xi by summation of fi. Remember, this is the mean. So to calculate the mean, we'll do this. So summation of fi xi is 382. And when we divide it by 40, we get 9.55. Now this mean is required over here. We will require the mean over here. So 6 minus 9.55 and sorry, this 2 minus 9.55 is minus 7.5. So this is not 6 minus 9.55. It is xi minus x bar. So xi is this values, right? So 2 minus 9.55 is minus 7.55. 4 minus 9.55 is minus 5.55 and so on. Okay. So this is xi minus x bar. So these are the deviations from the mean. Now we will square them up. So square it. So this is square of the square of the deviations from the mean. So minus 7.55 squared is 57.0025 and so on. We will square all these up. Now we will not sum this up because it is not an ungrouped data. It is for group data. So we'll multiply fi with the square of deviations. So what we will get? We will multiply this with this. Okay. So we'll get this column. So 3 times this value is this, 5 times this value is this, 4 times this value is this, 6 times this value is this, 2 times this value is this, and so on. When we get this value, we will sum those values up, and here it is 939.9. Now what we have to do? We will divide this number by number of observations, which is 40. So when 939.9 is divided by 40, 939.9 is divided by 40, we'll get this number. which is the variance. So what is this? This is variance. Variance is 23.4975. And how will we calculate standard deviation? Standard deviation will be just the root over 23.949. Okay. So we'll get this value 4.85. So what was the formula for variance we have used? Variance is equals to 1 by n summation of fi xi minus x bar whole squared. Okay. This is the formula for variance which we have used. So we have taken the sum and then divided it by n, which is 40 in this case. Okay. So this is how we calculate variance and standard deviation for discrete frequency distribution. And you see only this square which I have drawn, not square, rectangle, these two columns will be given in your exams. You will have to calculate everything else. So you should remember the first row of this table. How we will do it? The first column, the first element will be xi, the next cell will be fi, the next cell will be fi xi, the next will be xi minus x bar, the next will be xi minus x bar whole square, and then fi times xi minus x bar whole square. Okay. And when you will calculate all the elements, you just have to sum it up and then find the variance. And for calculation of the x bar, you have to use this expression. Okay. We have done a similar thing in when calculating mean deviation. When you go back to the previous lecture, you can see that it is very similar to what we have done when we calculated mean deviation. Okay. Now we will see how variance and standard deviations are taken for continuous frequency distribution. So the given continuous frequency distribution can be expressed as a discrete frequency distribution by replacing it each class with its midpoint. So if you remember when we were doing mean deviation and when we said the first class is 15 to 25, we took the midpoint xi as the midpoint of this value, which is 20 here. So similarly, we'll do here also. So whichever the class is, we will take the midpoint as xis. And what are we assuming? We're assuming that the frequency is centered about the midpoint. This is the assumption. So what is the assumption? The frequency of the class is centered about the midpoint. Okay, this is our assumption. The frequency of the class is centered about the midpoint. So whatever be the class, 50 to 60. So the midpoint we will take at 55 and we will calculate the deviations from this value 55. Okay, because this is what we have assumed. Now the standard deviation is calculated by the technique adopted in the case of the discrete frequency distribution. So when we calculate variance using this formula, it is same as what we have done in discrete frequency distribution. The standard deviation will be just the square root of the variance. So you see this formula and you see the previous formula. This formula, it is same. So what is the difference? You will ask, because this is for the discrete frequency distribution and the earlier one is for continuous frequency distribution. The only difference is here xi is taken as the midpoint of the class. Okay. Earlier we had xi is given. Here you can see in example xi were exact values 2, 4, 6, 7, 9, 10, 15, 18. But in this case, you can see xis have some range 10 to 20, 20 to 30, 30 to 40 and so on. So we'll use the same formula, but xi will be the midpoint of the class. So we'll go to the example and see what we have. We have x as the class. So this is the class of continuous x values. Okay. So the first class is 10 to 20, the second is 20 to 30 and so on. Okay. Now for each class we have a frequency. So we are saying that between this class we got one observation. So between 20 to 30 we got 5 observations. Between 30 to 40 we got 4 observations. Between 40 to 50 we got 6 observations and so on. Okay. So you can think of this as a marks of a class. So exam was conducted and we got marks of the students. There were 40 students in the class and one student scored between 10 to 20. Five students scored between 20 to 30. Four students scored between 30 to 40. Six students score between 40 to 50 and so on. So this can be just one example of marks of a class. Okay. So what will xi be? Xi will be the midpoint of the class. So 10 to 20 is midpoint is 15, 20 to 30 midpoint is 25 and so on. So these are all the midpoints of the class. Now everything else we will do is same as what we have done in discrete frequency distribution. So we'll calculate fi times xi. So 1 into 15, 5 into 25, 4 into 35, 6 into 45 and so on. We'll calculate this column. Now what we do? We calculate the mean because we need the mean here, right? So for the mean, we will calculate the sum of fi xi and then we will divide it by n. So what is the sum of fi xi? It is 2130. If you add these numbers, you can take some time and add these numbers. You will see that it comes out to be 2130. And when you divide it by 40, by the number or sum of the frequencies, this n is actually sum of the frequency. Okay. So you'll get 52.53.25. Now this mean you have calculated, you plug the mean here, which is 53.25. You take xi, so this is the xi 15 minus 53.25, which is minus 38.25. Again 25 minus 53.25, which is minus 28.25 and so on. You calculate the deviations and you take the square of the deviations. Why are we taking square of the deviations? Because variance is the mean of the squared deviations about the mean. Therefore, we are calculating the squared of the deviations about the mean. So this is the mean. Okay. So again, we are squaring it up. These numbers are just square of the numbers written here. Okay. Now we will not add this up. We will multiply it with the frequency. So this frequency and this column will multiply because we have observed those values by the given frequencies. We will multiply each with the frequency and then we will sum up. And what we'll do with the sum, we'll divide it by 40 because that is the number of times we have observed those values or the sum of the frequencies. So sigma squared, which is the variance, comes out to be 339.4375. And sigma, which is the standard deviation, is just the square of variance, which comes out to be 18.4542. Okay. So we have seen how we'll calculate variance and standard deviation of continuous frequency distribution, right? Now we will see another formula for variance. So now you know that variance is given by this expression. Sigma squared is equals to 1 by n summation of I equals to 1 to n fi xi minus x bar whole squared. Now if you square these terms, we will get 1 by n summation of I is equals to 1 to n fi xi squared plus x bar squared minus 2 times xi x bar. Okay. So we will take this term inside. So we'll get 1 by n summation of fi times xi squared plus summation of fi times x bar squared minus summation of fi times xi times x bar. So for simplicity, I'm not writing I is equals to 1 to n, but it is there. Okay. Assume it is there. I'm not writing in every sum. Now you see this term is a constant, x bar squared and x bar. What is x bar? X bar is the mean and mean of the data doesn't change. So mean is constant. So we'll take it out of the sum. Okay. Why we are taking out of the sum and how can we take it out of the sum? Because it is constant. Okay. This is not constant. For each I, xi changes, but x bar doesn't change with I. Okay, this is constant. This term is constant. So we'll take it out of the sum. So what we'll have, summation of fi times xi squared plus x bar squared summation of fi minus x bar into summation of fi xi. Okay. Now you see this summation of fi is capital N, right? N is equals to summation of fi. Remember? So we'll get 1 by n summation of fi times xi squared plus x bar squared into n. Now you see this term, you can write it in a different way. How can you write? Let me change the color for more clarity. You know, x bar is equals to summation of fi times xi by n, right? This is the calculation of the mean. So you can get summation of fi times xi as n times x bar, right? So we'll plug this value here. We will get n times x bar, right? You see, this x bar and this x bar we will multiply and we will get 1 by n summation of fi xi squared plus x bar squared and minus x bar squared. We had a 2 here. We had a 2 here. Where did we? Oh, we didn't write the 2. We had a 2 here. Okay. Minus 2 times xi x bar square into n. Okay. So this and this is same. So we had a 2 here. So we'll get 1 by n summation of fi times xi squared minus x bar square n. Okay. Now what we'll do? We will take this n outside. We will take the factor of n, 1 by n into n. When you take n outside, no, what will we do? We will take this n outside. Okay, just 1 minute. We'll take this n inside. Okay, so let me do that first. So we'll have summation of fi times xi squared by n minus x bar squared. Okay, now you see this is what? This is actually variance, right? We have started with variance and we got this also as variance. So variance can be expressed using this. So let me take it to the next slide and proceed. Okay. So this is what I will write in the next slide. So variance equals to, you see what we have done? Variance is this term. You can just go again and see that we have changed nothing. We have just expanded this squared and then we got this term. Okay. So we will have variance as 1 by n summation fi times xi squared minus x bar squared. Now you know what is x bar? X bar is nothing but summation of fi xi by n, right? So we will put this here. So what will we have? We will have 1 by n summation of fi times xi squared minus summation of fi xi by n whole squared, right? So we will have 1 by n summation of fi times xi minus 1 by n squared summation of fi, this is squared, into xi whole squared. Now I'll take n squared outside. So 1 by n squared, we will have n into summation of fi times xi squared minus summation of fi xi whole squared. So this is the formula for variance and this we will use and this will help because we don't have to calculate deviations. You see, it doesn't have any factor as xi minus x bar, or we don't need to calculate the mean at all. So for this formula, you don't have to calculate the mean. Okay. And what will be standard deviation? It will be square root of variance, which is nothing but 1 by n. You take the square root of this expression, which will be 1 by n summation of fi xi squared minus summation of fi xi whole squared, and this is under root. Okay. So we'll use this expression to calculate the standard deviation. So again, I'm saying we had one more formula. We had this formula, right? We had this formula. So why are we calculating so much and getting these two formulas? We are doing it because in these two formulas, we don't encounter the mean. We don't encounter this term. So we don't have to calculate the mean and then take the deviations. We just have to multiply fi and xi and then again fi times xi squared, and we will get everything else. Okay, when you see one example how we are using this formula, you will understand that it reduces, it sometimes reduces computational burden or calculation burden. Sometimes, not always, sometimes. Okay, so you can use either this expression or this expression to calculate mean and variance and standard deviation. Okay, so suppose, so I have written the formula here for clarity. Okay, standard deviation sigma is equals to what we have got, 1 by n root under of n times summation of fi xi squared minus summation of fi xi squared, fi xi whole squared. So what are the terms we require for this formula? What terms we require? We require summation of fi times xi. First thing we, second thing what we require is summation of fi times xi squared, right? So for this, to calculate this, we require xi squared. So three things we have to calculate, right? Three things we have to calculate. First this, then this, then this. Okay, three things we have to calculate. So we'll go to the next slide and see how we are calculating these three things, and then we'll go to the calculation of variance and standard deviation. So you see, I have the example here. So I have used discrete frequency distribution, but this can be done for continuous frequency distribution as well. We will say that this is the midpoint if it is a continuous frequency distribution problem. Okay. So this is xi, and xi's are these values 2, 4, 6, 7, 9, 10, 15, and 18. And you see this example which I have taken, it is same as what we have done earlier. And why I have taken the same example? See this example. Why I have taken the same example? To show you that this table is very big. You have to calculate this 57.0025 into 3 and this squared and so on. So much calculation was required to calculate mean and variance. Sorry, variance and standard deviation. So standard deviation you got 4.85 here using all these formulas. And also in the next slide, when we are using this formula, we are also getting sigma as 4.85. So the same value of standard deviation and variance you will get, because both the formulas are the same. Only computationally it is little bit less demanding. Okay, so you see we have xi and we have fi. So these two values you will be given. Up, not this, up till this. What is 40? 40 is just the sum of fi, or which is n. Okay. So n you require because n is here in the formula. So you have to calculate fi times xi. So we'll just multiply these two values. You'll get these values. Then we'll calculate xi squared. So 2 squared is 4, 4 squared is 16, 6 squared is 36, and so on. We'll calculate this squared. Now what we'll do, we'll multiply fi and xi squared. So we'll get this column fi times. Okay. Now we'll multiply this. So 3 into 4 is 12, 5 into 16 is 80, and so on. We'll calculate this. And what this is summation of fi times xi squared. So when we get these values, we add these up. These values we add up and we'll get 4588. Now what we do, we have these values, this and this, we will just plug it into this formula. So sigma, which is the standard deviation, will be 1 by n root under of n summation of fi xi squared minus summation of fi xi whole squared. So what is n? N is 40 root under of 40 times what is summation of fi xi squared? This value 4588. 4588 minus summation of fi xi whole squared. So summation of fi xi is 382 ka whole squared. So when you do this, you will get 4.85. This is the standard deviation. And for variance, you can just square this up. Okay. And you see the calculations required for this is very less as compared to what we have done here in this example. This is the same example which I have done now, and we have calculated the standard deviation, which is exactly the same as the previous one, 4.85. But you see the calculations and the table is little bit less computationally demanding. Okay, so again one more time, I am saying that this formula and this formula is the same. So this is for standard deviation. For variance, it will be sigma squared, which is equals to 1 by n squared. You can jot this down. Okay, summation of fi times xi squared minus summation of fi xi whole squared. So this is for variance. And how did we get this? We can just take a revision. So we had the formula for variance. I'll take another color for more clarity. So we had this formula for variance. It is the mean of the deviations from the mean. Okay, square deviations from the mean. The mean of the square deviation from the mean. So we are taking this, we are just expanding this. So it will be xi squared plus x bar squared minus 2 xi x bar. Now what are we doing? We are taking this sum inside. So it will be 1 by n summation of fi times xi squared. Here we'll also get summation of fi times x bar squared minus 2 times, because 2 was there, 2 times summation of fi into xi into x bar. Now you see this x bar is a constant. It is the mean. You take some values and you calculate the mean, it will remain same. It will not depend upon I, because this sum is over I. So you can take this x bar outside the sum. Okay. So we'll have 1 by n summation of fi times xi squared. So you see it is xi. So we cannot take xi outside the sum because this sum is over I. If the sum is over I, you cannot take xi outside the sum. But you can take x bar outside because x bar is not dependent upon I. So it was x bar squared. So we have taken it outside, and here it was x bar. Now this, you can write it as n times x bar. So we have written it n times x bar. And summation of fi is actually n. N is equals to summation of fi. Now you see this term is twice this term, right? X bar squared n minus 2 times x bar squared n. So we'll just subtract this and we will get this term 1 by n summation of fi times xi squared minus x bar square n. Okay. And we take this n inside. So when we take this n inside, this n and this n will get cancelled out and we'll get this. In the next slide, I have just taken this expression and simplified it further. So this expression we have got. Now what we'll do, we know x bar, which is actually this summation of fi times xi by n. So we'll plug in here. We will get this because this is just x bar. Now, when you squared it up, it will be n squared and this is squared. Now again, you take n squared outside. When you take n squared outside, you will have n times this minus this squared. So this is the formula which we were using for this table. Okay. So this is the formula for variance. And when you take the square root of this, square root of variance, you will get the standard deviation. Okay. So remember the formula for variance. We have taken two formulas. First is this formula, which will help you not to calculate the mean, not to calculate the deviation from the mean, and therefore not to calculate the square of the deviations, which becomes demanding. You see, when you have the square of the deviation, so you have the deviations as minus 38.25. So you have to square those deviations, which is 1400, 663.0625 and so on. So calculating this is a little bit demanding. Okay. And again, you have to multiply the frequency with this to get this thing. So these all calculations becomes heavy. So if you don't want to do it in some of the data, it will be more simple to use this formula, because you have to calculate FI xi squared and FI xi squared. Okay. And then you plug in these values, this value, this value, and this value in this expression, and you will get this. Now, one thing which is remaining to tell you is that this formula which we have applied, it is valid for both discrete TIS CRE, discrete frequency distribution, and continuous NUOUS frequency distribution. How we will use for continuous frequency distribution? You see, in again continuous frequency distribution, you will have a range 20 to 30, 30 to 40, 40 to 50, and so on. So again, for xi, you take the midpoint, which is 25. Here the midpoint will be 35. Here the midpoint will be 45. And this xi you take at here. Therefore, you will have xi. You can calculate fi xi. You can calculate xi squared, and you can calculate fi xi squared. Therefore, you can calculate their sums, and you can again use this formula. So this formula is valid for both discrete frequency distribution and continuous frequency distribution. So these are group data. And the thing is, you can also use it for ungrouped data with a little bit of change. In ungrouped data, you will not have FIs, right? You have to remember that. With a little bit of change, you can also use this formula for ungrouped data. Okay. This is it. So with this, we have come to the end of this chapter. We have seen what is variance, what is standard deviation. We have seen how to calculate it for ungrouped data, for calculate it for group data, for both discrete frequency distribution and continuous frequency distribution. I would request you to practice some problems and use the table. You have to use the table to calculate variance, standard deviation, mean deviation, and anything which requires this kind of tedious calculation. So table will help you to track. Everything will be there in the table. You just plug in the values and get the value of this data. Okay. Now data, the constructs or the values of this variance and standard deviation and so on. Okay. So I would recommend, please practice some problems. You can take these values itself. When you take these values and you do, you will have the answer. You will just have to use your mind and calculate these values and check if your answer is coming the same or not. Okay. Thank you.